Data Warehouse. My name is Kurdo Jaza Mahmoud, and this would be your Chapter 7. Now, our course outline would be first, the need for data analysis, business intelligence architecture, decision support data, data warehouse, online analytical processing, data warehouse design, start schema. We have many objectives, which would start with these, describing and explaining these following points, and by the end of this video you should be able to describe the need for data analysis, describe the business intelligence and its steps, explain the components architecture of a business intelligence, explain the tools used in business intelligence, explain operational business decision support data, describe contrasting characteristics of operational data and decision support data, explain decision support database requirement and the data warehouse characteristics, 12 rules, multidimensional data analysis technique, explain OLAP and the advantage, the advanced database support for OLAP, MOLAP, ROLAP, draw data cube, and start schema, explain the operation of a data cube. These would be our objective for this class. And it's kind of a lot, but the thing is, these are all important topics that you would need them for the entire slides. Now, introduction our first part would be, as we explained it in the class, also we would explain in the first slide, and it is that the data is a very important raw material in today's information age. What do we mean by information age? We mean that everything now is dependent on the information and data. Now, storing and managing data became main focus of a database design, or those who design a database or a database administrator, as you are guys. And the whole point of a collection data is turned into useful information. Or by another word, we mean that there's no usage of a data if I cannot use it for getting some information or some idea from those data. Now, a decision support system, DSS, were created to help with the decision-making process. Now, as a business grew more complex, it became harder to get all needed information from a regular operational database. Or what do we mean by operational database in here? We mean that it is not, let me choose the laser pointer, uh, operational database in here. I mean that the normal database or normal system that I created, I cannot get a lot of information from only the logs or only the reports that I would see. So a new type of storage was invented and we call it data warehouse. Now, a data warehouse pulls data from operational database or our system and external sources, giving a much bigger, richer data pool to work with. Now, data warehouse would take operational database or our system and external sources, any other sources of data. Uh, because of this, we would have a bigger pool of data so we can depend on. Now, do we need this or do we need data analysis? Yes, we will need it because organization grow and succeeds when they understand the environment better. Now, how would they would understand their environment better? It would be through the data. And of course, managers need to track daily transaction to see how the business is doing. And data analysis helps the answer short-term questions like this, or by another word, business questions. Are our sales promotion working? What percentage of the market do we control? Are we attracting new customer? Are our campaigns that we did it on Facebook, YouTube, TikTok was successful or not? Did it attract any new customers or not? And things like this. Now, a business face many competitive pressures, so managers always need to adapt. The thing is, when managers they would say we need the data that would tell us this, they will not say, well, we need to have a data warehouse, we need to know this and that, our system should know all of these and have these information. It is the job of a database administrator. Now, different level of management, they would need different type of information. Of course, managers they would need information to its detail to make it a good decision. Okay, they cannot make a decision based on only one or two or three lines. They would need a comprehensive information. Now, the need for a complete and comprehensive, organized decision-making system led to what? Led to business intelligence or BI. Now, these are the operational or junior management, or those who are the management. They would track the day-to-day decision. They would say, tells you day-to-day decision. It is simple and routine, and they would get the information from the tactical or middle management, and the middle management they will get it from the senior management. Now, the tactical and middle management, they will get let's say, a medium term or less complex orders, maybe monthly reports. They would get it, and the senior management would be the board, and they would process the information that they would get from the business intelligence, and they would decide for the next 10 years. Competitive advantage. For example, you have a supermarket, you have two options. Option one, selling the Coca-Cola with the same value of a competitors at a lower price. For example, the Coca-Cola next supermarket, there's a supermarket just 2 blocks away. They would sell Coca-Cola for $1. They would sell Coca-Cola, sorry, for $1, and you would sell it for, let's say, you would sell two for $1, or you have a higher price. You are selling, let's say, Coca-Cola with $2, let's say, instead of $1, but your Coca-Cola is original. So this is a competitive advantage. It comes from a matching what company does best or with the right opportunities. Now, we have a business intelligence, and this line is important. BI, because it tells us what is business intelligence is: a full set of tools and processes to collect, store, and analyze after all present. So collecting, storing, analyzing, and presenting of what? Data. Well, you may say, which kind of data? That data that the managers they would be able to do a business decision based on it. Now, simply, business intelligence is about learning the facts of your business to make a smarter decision. You would say, for example, if I did this campaign in summer, my customers they would like it and they would come. For example, the same campaign, if you did it in winter, there would be no customers. So you would learn the fact about the nature of your business, and then you would make a smart decision based on that fact. Now, BI can positively change company's culture by creating a business wisdom, because now anytime that you want to do something, you would return back to your data, and based on those data you would observe, and you would uh, know what decision you should make. And once you got the business wisdom, you need to share with your organization members. Now, the BI, collecting data, turn data into knowledge, and then share knowledge across the company. So you would collect the data, that would be the job of your system or external resources. Now, turning data into a knowledge, a business intelligence, let's say, it would do this. Now, once you did that, what you need to do is share that knowledge across your company or your organization. Now, BI is not a single product. It is a framework of idea and tool and technology. So if I asked you, BI is only the ideas that helps business understand itself better? No, it is the ideas, tools, technologies, and so on. Now we have these steps of BI creation: collect and store operational data, aggregate data into decision support, and analyze data, generate useful information, present information to end user, make a business decision, lastly monitor the results. And these rules are, we could say that these are the main steps, and most of the organization they would go through these steps. Sometimes they would add another step in here, but this is the standard and you could use it also. Now, the business intelligence architecture, or the business intelligence by itself covered the wide range of a technology to manage entire data lifecycle. From where? From the first step, collection, all the way to storage, analysis, and archiving. Now, BI functionality range from a simple data gathering to very complex data analysis. So it is not only, let's say, data collecting or gathering. Sometimes it go to the very complex data analysis too. Now, there's no single BI architecture. It varies by organization. For example, we have, let's say, an architecture in the next slide. It is not, it is kind of, we could say, standard, but by the organization type and the nature of the work of that company organization, BI would change also. Now, however, all BI systems share same common type of functionality. Now, these are the common functionality. We have people, we have process, we have governance, and we have management. Now, this is business intelligence framework. We would have external data and we will have operational data. Now, this operational data, let's say this is the system that you would create for an organization, and external data would be the data and the information that they got from the campaign in a Facebook or advertise an ad from Facebook, YouTube, TikTok views, and so on. They will feed all of it to ETL, extraction, transformation, and loading. Now, once they feed it into the ETL, it will go right the way to the data warehouse. And we would have a data mart that we would explain it later, which we call the step entirely data store. Now, after that, we would have a query and a reporting. Now, from the query and reporting, we would have monitoring and alerting, and we would have data analytics. From that, of course, not everyone knows how to read and understand the complex data, so it is a better practice to uh, create a data visualization. Based on those data that you got from the query, you would create a framework, or let's say you would create a Gantt chart or a line chart or a bar chart, and so on. We have the type of charts that we would explain it in the next slides. Now, architectural components. We talked about ETL, data store, data query, and data presentation. And this was the ETL, data store, query reporting, and data visualization. Now, the ETL tool will extract and filter, transform, aggregate operational data from internal and external sources. Then, of course, once it does this, it will feed it or load it into decision support data store. Now, what is data store? Data store will be data warehouse or data mart optimized for a fast query and analysis. Now, if we directly went to the data itself, we could not, maybe we will not be able to get a very good answer. Why? Because in a data warehouse, the data are optimized for a fast query and analysis. So the data in the data store would be optimized, or they would be better form and organize it in a better way. Contain business data, operational, external, of course, we know this, and business model data generated by the algorithm. Now, data query and analyzing tool perform a data retrieval, or it will retrieve the data and mining from the data store. It will think instead of us, and it will use some algorithm for data mining, using what? Using the data store or operational DB, often implemented as a OLAP tools. Now, what would an OLAP tool do? Uh, what OLAP tool would do for us? It will do a data mining and data retrieval for us based on those data that it mined. Now, help analysis build a reliable business model. Now, presentation and visualization tool present data to users via reports, map, pie, or bar, or Gantt chart, or mixed graph, any way, any form of presentation or visualization for the upper management. Now we have a sample of the BI tools. We have a DSS, we have a dashboard business activity monitoring, we have a portal, we have a data analysis reporting tool, data mining tool, data warehouse, OLAP tool, and data visualization. Now, these are the tools, and these are the short description, and this is a simple vendor or sample vendor for each one. Now, for a decision support system, we have a SAP, Teradata, IBM, or ProClarity. Now, for dashboard and business activity, we have Salesforce, Visual Call, and Cognize IBM Business Object, Information Builder, and Actuate. Now for the portal, we have the Oracle portal, Actuate, and Microsoft. For data analysis, query multiple diverse information source to create integrated report. We know it's for reporting, SAS, Web Report Studio, and so on. Now, these are all important. However, we have something in here, data warehouse, Microsoft, Oracle, IBM, Cognos, MicroStrategy. Now, what is OLAP tools that we explained it in the previous slide in here, OLAP tools. It's an online analytical processing for a multi-dimensional data analysis. Now, if we have a data that it has multi-dimensions, we would use an OLAP tool. Now, Cognos IBM Business Object, Oracle, Microsoft, and the data visualization, of course, it will visualize the data. We have Dundas and iDashboards. Now, practice to manage data. Three more important practice organization used to manage data well. We have MDM, Master Data Management. We have governance. We have Key Performance Indicator, or as we call it, KPI. Now, Master Data Management would be a set of concept and process to properly doing what? Identify, define, and manage. Three things of what? Important data element within organization. Now, governance would be a method or process to controlling and monitoring business health and ensuring the consistent decision making. Now, key performance indicator, it could be numeric or scale based. Of what? Of a measurement. Now, you would say, why do I need a measurement? Either it is scale based or numeric, because it show us how effectively company is reaching its goals. Now, the visualization that we said, we have a pie chart like this. We have a line graph, line. We have a scatter plot. We have a Gantt chart like this, and we have a heat map just like this. Now, these are the type of data visualization. For some reports, we would need a pie chart. For some, we would need a bar chart just like this. Some would be line, some would be heat, some would be Gantt chart. It work uh, in the, or we should uh, decide which one to use based on the way that, for example, the company wants to see the data. Now, a modern or a reporting style of a modern BI system, we have three type of report or three style of a reporting: advanced reporting, monitoring and alerting, advanced data analytics. Now, advanced reporting, it would be creates a detailed or customized report from a data. Monitoring and alerting, track performance and send alerts, or instead of alert, we could say also notification when something unusual happen. Now, advanced data analytics applies complex analysis to discover deep insight. Now, business intelligence benefit would be improved decision making, integrating architecture, common user interface for data reporting and analysis, common data repository for faster single version of a company data, improved organizational performance. Now, it was just like this, or doing the file system, or let's say a big notebook that they will write everything on it in the 1970, or in the 90 after from the 1970 to 1979 and so on, or 1989 or 1980s. These spreadsheets were developed and they used spreadsheet, then enterprise reporting. Now OLAP and mobile BI came in the late 2010. So after that, everything changed, and from a simple spreadsheet, they went to for OLAP or mobile business intelligence. Now, these were the technology trends of a BI: data storage improvement, business intelligence appliance, business intelligence as a service, Or by another word, these came so it became necessary for business intelligence to adapt itself and the companies to adapt business intelligence tools and the idea itself, and a big data analytics, personal analytics too. Now, decision support data, the we could say that if we want an effective BI, it should be or it would depend on the quality of a data, not quantity. This is what you need to be aware. Quality is more important uh, compared to the quantity. We like quality in the business intelligence. Now, the quality of the data, those data that are collected at the operational level, operational data, is usually not well suited for decision support because it is stored in a highly normalized relation database optimized for daily transaction, not analysis. Now, by another word, I'm telling you that the operational data or that where we would get the operational data from our system that we created it, and it is not that good for this, let's say, deciding whether to do this campaign or not because they are not intended to for business intelligence. They are intended for a daily or day-to-day transaction. Now, decision support data different from operational data in three ways. Actually, in these ways, and it would be from a time span, uh, it would cover a longer period of time from granularity, level of detail in the data, from a drill down breaking down data into lower or more detailed level or zoom in, roll up or zoom out, aggregated into a higher summarized level, and dimensionality decision support data has a multiple dimension, time, location, and product. Now, decision support database requirement. For a database to properly support decision making, it need to meet these requirements. Category, database schema, data extraction and loading, and database size. Now, database schema must support complex non-normalized data, okay? And aggregated and summarized data and query that extract multidimensional time slices. Now, data extraction and loading allow batch and schedule extraction, support different sources, check for inconsistent data, support advanced integration and classification. Now, database size would be must support very large database advanced storage technologies, and multiple processor technologies. Now, what is a data warehouse? A data warehouse is a central storage place where data from operational database and other sources is collected, cleaned, and standardized, all to support decision making. Now, the official definition has four key properties: subject oriented, integrated, time variant, and non volatile. Now, these are just these. So we have it in two slides. Now, either we call them characteristics or we call them properties. Properties and characteristics are the same. Now, a subject-oriented means organized around specific subject, integrated combined data from many different sources, time variant keeps historical data over time, and non-volatile. Once data is stored, it will not be changed in a data warehouse. Now we have some videos about data warehouse. If you wish, you should take a look at it and you would understand it better. Now we have the characteristic of a data warehouse versus the operational database. Characteristics of a data warehouse versus operational database. In terms of purpose, operational database run daily business operations where data warehouse support analysis and decision making. Now, the data type would be current up-to-date data, but the data warehouse, we would have historical summarized data, and we would have data from different sources. Now, from the term of structure, normalized many small tables, or by another word, I mean that the operational database would have many small tables so that every uh, specific job would have its own table, but the data warehouse, it would be denormalized, fewer larger tables. Users would be clerk, frontline staffs, and so on, but the users of a data warehouse would be manager, analyst, and executives. From the query side, it would be simple and repetitive, but for the data warehouse, it would be changed, and the complex and analytical queries would be used and will be requested from data warehouse. Now, the updates, frequent, insert, update, and delete. However, in the data warehouse, it is rare, loaded in batches. And of course, Opera database would be smaller compared to the data warehouse where it has the data from many sources and many other systems. It would be very large, gigabyte to terabytes. Now, this is a diagram of an ETL process or extraction, transformation, and loading. We would have a data operation in here. We would have the operational data in here in different sources, and we would extract. We would have the extraction phase where we load it to the transformation, and we would do filter, transform, integrate, classify, aggregate, and summarize, and then we would load it into the data warehouse. Now we have 12 rules for data warehouse. If the data warehouse, the first rule is the data warehouse and operational environment are separated. The data warehouse inside it, in the data that are inside it are integrated from different sources. The data warehouse contains historical data over a long time, so there's no concurrency in here. The data warehouse data are snapshot data captured at a given point in time. The data warehouse data are subject oriented, and data warehouse data are mainly read only with the periodic batches update operational data. No online update are allowed. Now, from the rule 7 would be the data warehouse development lifecycle differ from a classical system development. Data warehouse development in data is a data-driven, classical approaches in process driven. Now, the data warehouse contains data with several level of detail. Current detailed data, all detailed data, lightly summarized data, and highly summarized data. And so it has all of the levels. And also the environment is characterized by read only. So there is no editing in the data warehouse. It would be only read only transaction to a very large data set. The operational environment is characterized by numerous update transactions, few data entities at a time. By another word, data warehouse, it would be read only, not uh, and we would have operational database where we would have updates and it would be something normal. Now, the data warehouse environment has a system that traces data sources, transformation, and storages. The data warehouse metadata are a critical component of this environment. The metadata identify and define all data element. The metadata provide the source, transformation, integration, storage, usage, and relationship, and history of each data element. And lastly, the 12th rule would be data warehouse contain a chargeback mechanism for a resource users that enforce optimal use of data by the end user. Optimal use of the data means that the best way to use data by the end users or those the users that would use data warehouse. Now, why do we need data warehouse architecture? Because the problem started with uh, many projects have failed due to poor planning and bad performance. So data warehouse projects are large and complex. They require coordination across many parts of an organization. Now, having a proper architecture help avoid these problems by providing structure and a clear plan. Now, we have a two-tier architecture, and we mean this one is the two-tier architecture. Now, in this architecture, users use the department directly use the data warehouse, no middleman, no data marts. Now, you may ask me, what is data marts? We would see what is a data mart. Now, operational data is transformed and then transferred straight to the data warehouse. So we would have operational data from our system. We will transform it and straight we will transfer it to the data warehouse. A separate layer of a server may be used to handle a complex transformation, of course, to make it easier to do this transformation. And enterprise data model EDM is created to support this, which we have this EDM role, and what it does, it has these roles. The enterprise data model describe the structure, contain metadata, and handle cleaning. Now you may ask me, what does the describe structure means? Define it would it would be define how the data warehouse is organized, and containing metadata, store info about data transformation rule, and handles cleaning details how to clean integrate data sources. And this is two-tier architecture. We have the operational database in here, and it would be right the way to the data warehouse server. And from there, we have also a detailed summarized data, or EDM, data warehouse. Now, from that server, the user departments, they would all access this server, and from this server, it will go to the data warehouse, and the data warehouse will get the information that each computer or each department would need. Now, three-tier architecture. In this architecture, users access data marts instead of full data warehouse. So you see in here, through this data warehouse server, we are actually accessing the data warehouse itself. But in this three-tier architecture or three-level architecture, the users, they will access the data mart instead of a data warehouse. It would be a smaller and focused storage unit called data mart, are used to give users faster access while keeping different user group data separate. For example, we have in our data warehouse, we have everything in here. However, data mart will solve this. It will create this data mart and this server. Now, another server and another data mart. And of course, we have still the data warehouse, the big data warehouse, but we will create these small data marts. So let's say this department, they will go to this data mart, and it has all of those information inside it that they would need it from the data warehouse. So it is like a middleman in this between. Now, if you ask me what's a data mart, here's the definition. The definition is a small subset or review of the full data warehouse. Scope, usually a department or a functional level, marketing, finance, sales, and so on. The role acts as an interface between users and corporate data warehouse. From the content, stores only a relevant subset of the warehouse data, and as we see it in here. Now we have the corporation, we have the enterprise data warehouse in this one, and we have the department, for example, accounting, finance, development, production. Each one from this big data warehouse, they will have their own data mart. So now from the finance, if they wanted to access the data warehouse, they would not go in directly to the uh, enterprise data warehouse or the big data warehouse. They would go to this data marts that eventually these are connected to this, but it is easier for the finance to access this one. Now we have a bottom-up approach. In this approach, data marts are built first for individual department before any full data warehouse exists. Data is modeled when entity at a time and stored separate data marts. Over time, new data cleaned and merged into existing mart, or a new mart are created. Eventually, all this data mart can evolve and grow into a full data warehouse. Now we have three stages: start, middle, and the end. In the start stage, build the individual data mart per department. Now in the middle age, we would have clean and merge new data into existing marts. So we would bring more data into these marts that we created in the first step. Now at the end stage, data marts grow and combine into data warehouses. So we have these data marts. Once they are grow and they have a lot of information, by all of them, they would be creating the data warehouse. Now we have operational databases in this part, and we have a data mart tier, data mart tier, data mart, and we have the user departments that each one they will access the server that is dedicated for the department. Now we have Oper Mart architecture. Now you may ask me, what is the Oper Mart? Oper Mart stands for, or it's a short for Operational Mart. Oper Mart, Operational Mart. It is just in-time data mart, built quickly when needed. Usually built from one operational database in anticipation of or in a responce to a major event. Now, it supports peak demand for reporting and business analysis that comes with that event. Now, what are the features from the type just-in-time temporary data mart? Now, the upper mart would be a temporary data mart also. Now, the source would be built from one operational database. We have a database in here, let's say, and from this, we will create these operational mart. Now, the purpose would be handle sudden high demand for reporting during a major event. Now, as an example, a retail company building a mart before a big sale season. It would be a good example for this. Now, online analytical processing or OLAP. Now, OLAP, an advanced data analysis environment that support decision making, business modeling, and operation research. Now, OLAP has three main characteristics. Multidimensional data analysis. So a data is not for example, only one dimension. It could have time, location, and product. In these three dimension, it would be analyzed. Now, the advanced database support can access many type of database and large volume of data, and easy to use end user interfaces designed so that non-technical user can easily navigate and analyze data. Now, multidimensional data analysis techniques. In OLAP, the data is processed and viewed as a part of multidimensional structure like a cube. Now, we will see what is a cube in the other slides. Now, we will return back to it. Now, the OLAP provides several powerful argumentation function. Now, the function type would be advanced data presentation, display data flexible, visual, and a meaningful way. Advanced aggregation, consolidation, and classification, group and summarize data into different levels. Advanced computational function, perform a complex calculation across dimensions. Advanced data modeling, builds models to represent and analyze business scenarios. Now we have table data warehouse invoice and data warehouse line. Now these are the operational data. We know this. This is the database that we work with. Now you may say, well, what is this? I would say that this is a multidimensional view of sales. Now, customer dimension we have from Summer Lake, Tridon, and also this one. From the time dimension, it will tell you from the 15th of May 2010, 16th of May 2010, and it will tell you the total. And for example, now this is a total, also this is a total of this. So it is not only from one side, it is from different side, from the customer dimension, from the time dimension, and from the total dimension. Now, advanced database support or OLAP to work for OLAP to work effectively, database behind it must support advanced feature. Now, for example, you are using OLAP, but also the database also should support these advanced features that you want OLAP to do it for you. Now, advanced data access, advanced navigation, query performance, it need to be very fast and smart mapping and very large database support. Now, advanced data access many different database management systems like Oracle and SQL Server, MySQL, and so on, flat file, internal, external data sources, and so on. Advanced navigation quickly move through the large amount of data. It should support this. And the query performance, fast and consistent response time, even for a complex query, it should provide us with a very fast responses. And smart data mapping, automatically map user requests to data, rights sources, and access languages. Very large database support can handle very large database, terabyte of data. Now, easy to end user interface. A properly implemented OLAP interface leads to simple navigation and faster decision making. Advanced OLAP features are only useful if the interface is kept simple enough for users to access them. Many interface features are borrowed from older generation data analysis tools like spreadsheet and reports. Now, the key points in here is simple navigation, faster decision, and familiar design. Simple navigation means users can move through data without technical knowledge. Faster decisions means easy access. or quicker analysis and quicker action. Familiar design built on concept user already know from older tools. Now, this is the OLAP architecture. We have the external data or operational data. We will feed it into ETL, and ETL will transform it, do its magic, and it will send it to the data warehouse. Now, we have an alternate direct access of operational and data warehouse data. Now, from here, we can feed it also the data as we can feed it, and also we can take it from the data warehouse itself. Now, once we take it, for example, from this side, the analytical processing logic and data processing logic will happen, Excel plugin, Access plugin, OLAP GUI, and so on. And of course, using this OLAP engine, we will have advanced reporting, spreadsheet report, OLAP report, dashboard, and mobile BI. Now, this is the main architecture, and we have OLAP server with main miniature data marts. Now we have the OLAP server. It will have the data warehouse and operational data that takes information from it, but we will have a multiple OLAP client accessing the OLAP server. And from there, the GUI would be provided for customers, marketing, production, and vendors. And now we have roll up. When we say roll up, we mean relational OLAP or the R OLAP, relational OLAP. Now provide OLAP functionality using relational database and familiar relational tools. It stores and analyze the multidimensional data using existing relation database technology, for example, SQL based. The key feature of a relational OLAP is multidimensional schema support, optimized query language, and very large database support, familiar technology. Now, multidimensional schema support as multidimensional data structure inside the regular RDBMS or relational database management systems. The optimized query language data access and query performance are tuned for multidimensional analysis, support very large databases, and the familiar technology uses standard relational tools, no new database system needed. Multidimensional OLAP extends OLAP functionality to multidimensional database management system. Now, multidimensional database management system use property techniques to store data in a matrix like n-dimensional arrays. End user visualize stored data in a 3D data cube. Now, grow to n dimension became in a hypercube held in memory in a cube cache to speed access. Now we have sparsity, measure the density of the data held in a data cube. Now we have relational versus multidimensional OLAP. From the relational, characteristic would be from the schema use the star schema, but the MOLAP use data cube. Now database size, it is medium to large, but already multidimensional is a very large database size. From the architecture, client 7 standard based, but this one also would have open or proprietary depending on a vendor. Access support ad hoc requests, unlimited dimensions, but limited to predefined dimensions, proprietary access, and speed, good with small data sets, but also the MOLAB would be faster for large data sets, predefined dimensions. Now we have a multi-dimensional presentation and we have the relational database representation. Now from the multi-dimensional, we would have the location from and the product will have monolaser, inkjet, photo, portable, and so on. But in a relational, we would have a monolaser, we would have California, Utah, Arizona, Washington, and Colorado, and the ink itself. Now, this way it is easier kind of to understand. However, this way we have somehow, we would say that we have a lot of duplicates. Now, we have a three-dimension data cube. Now, instead of this or that, also we can have something else, the three-dimensional data cube. We will call it the data cube. Now, we would have from the location dimension, from the product dimension, and from a time dimension. From the time dimension, it starts from the 1st of Jan 2026 to 31st of December 2026, 2006, sorry. Now, from the product, we would have mono laser, inkjet, and photo portable, and so on. Now, this is a three-dimension data cube, and this is a multi-dimensional representation. Now, from the product and a time and location, we could have North America, we could have Asia, Africa, Europe, and the cards, and of course, based on a time, the time range 2008, 2009, 10, and 11. Now, this is also another example, and marketing database, sales database, or customer database, product database, for example, 1, 2, 3, 4. This would be the product line, and we would have a time advertising, customer segment, we would have a year, and North Territory, South Territory, Southwest Territory, and East Territory. So again, in the representation of the data. Now, multidimensional representation with the raw total. Now we have the location, monolaser, and so on, Colorado, Washington, and so on. Now we have a total. So we would have another dimension, location, product, and a total. Multidimensional terminology. We have a dimension, we have a member, and we have a measure. When we say dimension, a subject label for a row or a column. Could be time, product, location, and so on. A member, a specific value within dimension. January in the time dimension. Now, for example, in here, let's say this 60, this 45, the 35 would be a member. Now, the measure, the actual numeric data stored in the cells as like this. Now, in here, because we didn't have the time, for example, in here, we could say this. Now, the Jan would be the member, and the measure would be this 45 and this 60. Now, same idea we have it in another table. So this slide and this slides are same. Now, dimension deep dive, you have a top level, middle level, and bottom level. Now, from the dimension can have a hierarchy, meaning member can have a sub-members beneath them. Example of a location dimension hierarchy. For example, we have a Malaysia. We have inside the country of Malaysia, we have Selangor from the state, and from the state uh, bottom level, we will have a city of Shah Alam. Now, in Iraq, let's say we would have Slemani, and inside Slemani, for example, would have Arbat, or let's say Raparin, Bakrajo, or any other things. I know it is not a city because the Slemani is not that big, but we can say uh, it is the same idea. We would have a country. Inside that country, we would have an area, a bigger area, and inside that bigger area, we would have smaller areas. Now, the drill down and a roll up, we have the direction and what it does. Now, the hierarchy allows two powerful operation. We call it drill down and roll up. The direction of a drill down would be top to the bottom. Go from a general to more specific detail, and as I said it in class, drill down would be like a zoom in. Now the roll up would be like a zoom out, and it would be from the top to from the bottom to the top, and it would go from a specific detail to a general summary. Now measure, we would go inside the measure. Uh, we would deep dive into it, and we would talk more about it. Now the measure are the numeric values stored inside the cells of a data cube, as we explained it. Now these are the measure. They can involve simple arithmetic or more complex statistical calculation. Any single cell can hold multiple measures at the same time. Example, a simple measure sales amount of a number of units sold, or a total ringgit cell. Ringgit is the price, the money or the currency of the Malaysia, equal total units sold, unit price. Now we have a derived measure can be pre-stored in a data cube, faster access, or computed on the fly from the other measure when needed. Now, data cube operation, we have these five main operations: slice, dice, drill down, roll up, and pivot. Now, the slice focus on a subset of a dimension. How does it work? Replace the dimension with a single number value or a summary of its values. Now, dice operator focus on a subset of a member value. Replace a dimension with a smaller group of members. Roll, drill down, and roll up. We explained it, get more detail about the dimension, like a zoom in, roll up, like a zoom out, summarize detail about dimension. And the pivot present data in a different order. Rearrange the dimension to the cube look different. Now it is same as this one. Now slice operator focus on a subset dimension. Now we would go deep dive into it. Similar restriction operator, dimension are set to specific value, and for example set dimension to specific value like uh, 1st of January 2006. Now this is an example for a slice operation. We have a location, monolithic, product, and portable. We would have, for example, in here it would be the the year and so on. Now, example of a slice summarize operational. You see, we have this, and we have a total sales. Now, we would say for the January month, how much sell did we have? And from the for the February, how much sales did we have? And what is the total sales for all of the year, from the Jan to the December? Now we have a dice operator, focus on a subset of a member value, replace dimension with the subset of a value. Dice operation often follows the slice operation. So after the slice operation, we would have a dice operation. Now we have Utah or Utah, which is the location. We have a monolaser 90 unit being sold, inkjet 90 unit, 40 unit and 90 unit, and from the photo 50 unit, and the portable it would be 30 unit being sold from these products. Now the drill down would be going inside the detail, navigate from a more general level to a more specific, obtain more detail about the dimension. For example, you want more information about uh, Utah, we have a Salt Lake, Park City, and Ogden. We would have information about all of them. And for example, we have Arizona, Washington, Colorado, and so on. Now, from Utah, we have the information about these three areas of Utah. Roll up or drill up or remove detail from the dimension. So instead of going inside Utah and say Salt Lake, Park City, and Austin, we will say only Utah or America by itself. Uh, Now we have the pivot. Rearrange dimensions so that data cube can be presented in a visually appealing order or in a way that we like it more. Now, most typically use of a data cube of a more than two dimension. Now, test your knowledge. We would have some test of your knowledge slide. We would have sales. We would have a product. We would have a custom ER, and we would have a sales PEO. Now, draw a 3D picture of a data cube. Assume that all values that are missing from the sales tables are 0. Now, you could use the data cube to represent these tables. Now we have a star schema. The data modeling technique map multidimensional decision support into a relational database. Now it creates a near equivalent of a multidimensional database schema from the existing relational database. And it return or yields an easily implemented model for multidimensional data analysis. Now, the component of a star schema would be fact, dimension, attribute, and attribute hierarchy. Now, Facts would be numeric value that represents specific business aspect. The dimension would be qualifying characteristics that provide additional perspective to a given fact. Now, the attribute use it to search, filter, and classify facts. Slice and dice, ability to focus slice on data queue for a more detailed analysis. And attribute hierarchy provide a top-down data organization. Now, star schema representation, facts and dimension represented by a physical table in a data warehouse database. We would have a many to one relation between fact table and each dimension table, and fact and dimension tables related by foreign key. Of course, when we have one to many, we have a foreign key in that between subject to primary and foreign key constraint. Now, primary key of a fact table is a composite primary key because the fact table is related to many dimension tables, always form a combination of foreign key pointing to the related dimension tables. Now we have the technique used to optimize data warehouse design. Normalizing dimensional table, we would have a snowflake schema or snowflake blueprint or whatever you call it. We call it schema in database. Now dimension table can have their own dimension tables. Maintaining a multiple fact table to represent a different aggregating level, denormalizing fact tables. Now, technique used to optimize data warehouse would be partitioning, replication, periodicity, and snowflake schema also was the under the another schema for normalized dimensional tables. Now, for partitioning and replicating tables, we have partitioning or splitting table into subset of row column places them close to customer location. Replication, making different copies or copy to table place different location. Periodicity provide information about the time span of a data stored in a table. Now we have a fact and dimension. We have location, we have a customer, we have a time, we have a product. Now this is like a star, one index between and others connected to it. Now the relation would be one too many between these. Now also we have this. Again, it is like a star. For example, now dimension table, fact table, dimension table, dimension table, dimension table. Now this is a fact table. This would be a dimension table, and dimension table. Now, because this one is in the between, it would be a fact, and these all would be the dimension. And you see that, for example, the primary key in here, we have a period code. Also, we have the store code. These are primary key in here, but in here it would be a foreign key. Now, constellation schema. Data modeling represent multidimensional database. Constellation schema contain multiple fact table in the center related to the dimension table. So instead of only having one table, we would have multiple fact table. Typically, the fact tables shared some dimension table. Uh, Multiple fact tables shared dimension table viewed as a collection of a star diff galaxy schema or fact constellation. Now, you see we would have more facts in here or more table. Now, for example, we said that these are the dimension table and this one is the fact table and this is a dimension table. But when we have like this, we would have, for example, this is a fact table and this is a fact table too. And these would be the dimensions or the leaf tables. But what is important to know is that this one would be the time inventory, or we would have the time dimension, store dimension, item dimension, customer dimension, and so on. We have a snowflake schema. Data modeling represents a multi-dimensional database. Snowflake schema has a multiple level dimension table related to one or more fact table. So one fact table or more. The snowflake schema, instead of star schema, of a star schema for a simple dimension table that are not in 3NF, free normal, third normal form. However, the snowflake structure can reduce the effectiveness of a browsing since more join will be needed. Now, this is also an example of a snowflake schema. We have the item, we have the customer, we have a time dimension, division, store, and so on. But we have sales in here. Now, this sales would be the fact table. For example, we could have more fact table also, but at that time we would have the dimension tables too. Now you have this one, you could create a fact table and a dimension table using the snowflake schema. We have the data analytics, encompass a wide range of mathematical, statistical, and modeling techniques, extract knowledge from a data subset of a business intelligence functionality. The classification of tools would be explanatory analytics, predictive analytics. Now, the explanatory analytics focus on discovering, explaining data characteristics and relationship based on existing data. However, predictive analytics will focus on predicting the future outcome, not on discovering and explaining data characteristics. Now, predicting future outcome of a high degree of accuracy. Now, data mining, analyzing massive amount of data to uncover hidden trend, pattern, and relationship. Form a computer model to simulate and explain the finding. Use the model to support business decision making. Running two mode, guided or automated. Now, extracting knowledge from a data. We would have a data, we'd have information, and we would have a knowledge. From the low to the high, and the knowledge as we explained it in the first chapter, it would be what we seek. Now, data mining phases would be data preparation phase, data analysis and classification phase, knowledge acquisition phase, and prognosis phase. Now, in the principle of data management, you would study the data mining in detail, and all of the steps would be explained. However, in data preparation phase, identify data set, clean data set, and integrate the data set. Now, data analysis and classification phase would be classification analysis and clustering, sequence analysis, link analysis, and trend uh, and deviation analysis. Knowledge would be select and apply algorithm, neural network, uh, in decision tree, inductive logic, clustering, regression tree, nearest neighbor, visualization, and etc. Now, at the last would be modeling, forecasting, and eventually prediction. Now, the predictive analytics employ a mathematical and statistical algorithm, neural network, AI, artificial intelligence, and other advanced modeling tools. Create the actionable predictive model based on available data. Next logical step after data mining. Now, adds a value to organization. Why? Someone asked you because it help optimize the existing process, identify hidden problems, and anticipate future problem or opportunities. And we reached the end of the slides. I hope you understand it. And if you had any question, please feel free to email me and ask your question. Thank you very much.